In this video, we are going to discuss about how to create a vector data in QGIS. To create a vector data, open the projected topographical sheet on your canvas. Then click on Layers on menu bar, followed by a click on Create Layers. Then click on New Save File Layers. Now we can see a pop-up window. On it, click on Browse button located at the right side of file name. Go to the specific folder where you want to save your vector data. I am saving in the folder called Georeferencing on desktop, where I have saved my georeference and projected topographical sheet. I am giving imp_places as file name, as I am going to digitize important places on the topographical sheet using point vector data. Note that the file is saving in .shp format, which is save file format. Let the file encoding as default. Click on the drop down icon of geometry type. Here we can see point, multi-point, line and polygon. Click on point. Make sure additional dimension is none. Then select CRS button and type UTM43N on the filter. Now we can see phi coordinate system on the preferred CRS window. Among those, select WGS84/UTM zone 43 north, which is having EPSG code of 32643, which we have assigned for our topographical sheet. It is important to remember that all the data we use in single project should have same coordinate system. Now click on OK. Look at the new field. Here we are going to add the column name that should be added in our attribute table. As we are going to create a point on the important places, I would like to create a column in the name of place name. Thus, I type p_name. Why do I use p instead of place? It is recommended to have short, understandable name instead of having lengthy name, because only 10 letters are allowed to have as a column name. Why do I use underscore instead of space? Because creating column name with space may not be understandable by computer languages. Hence, in the place of space, I use underscore. Click on the drop down icon of type. Here we can see 4 options. The first one is text data. If you want to type alphabet or numbers with alphabet and special signs, we should use text. The next one is numbers, which allows to enter only whole numbers. For example, population data, which always be in full number like 10,000, 1,500 or 750. The third one is decimal numbers, which allows us to enter decimal numbers. For example, rainfall data 350.56 millimeter, 750.73 millimeter. The fourth one is date, which allows us to enter the date information like 13th day of 6th month 2020. In this case, we are going to enter name of the place. So we should select text. Look at the length. Here we have to mention the highest length of name we enter in the table. For example, if we mention 4 here, we cannot enter the name Hyderabad because the length of Hyderabad is longer than 4. I give length of name as 18, assuming that there may not be any name more than the length of 18. The precision is available only when we use decimal numbers to decide how many decimals should be in our attribute table. Click on Add to Field List. Immediately we can see the entered information is added in the field list. We can also see there is an ID information in the type of integer with the length of 10. It is a default column which is created by software itself. If you need this column, we can keep it, or else we can remove by selecting it followed by a click on remove field. Here I have added only one attribute column in the attribute table. If necessary, we can add several columns as per our need. We can also add or edit or delete columns in the attribute table in the later stage. Now click on OK on New Save File Layer window. Now we can see a point vector layer is added in the layer panel on top of the topographical sheet. See the name important places, which we have assigned at the time of saving vector data. The dot left side of name indicates type of data, which is point in this case. The checkbox in the left side of the data helps us to hide or unhide the data on canvas. As we have not created any data in important places, click on checkbox of Pro Image to understand how it works. Right click on important places and click on Open Attribute Table. Here we can see two column names such as ID and name. Remember, these names we have assigned at the time of layer creation. Close the attribute table and right click on vector layer and click on properties. Click on the information tab and confirm the projected coordinate system of data. By seeing this, we can understand the coordinate reference system is EPGSG:3264-WGS84/UTM zone 43 north-projected. By seeing the coordinate system, we can understand the data is having correct projected coordinate system. Then close the window. Now zoom and pan the place that you want to digitize or where you want to create the point on the topographical sheet. Now look at the tools at digitizing toolbar. Except angle editing tool, all other tools are hidden. These tools will be activated only when we activate toggle editing tool. To activate other tools and start digitize, click on toggle editing. If you don't have this toolbar, open it by right clicking on empty space of toolbar. Now we can see few tools activated. Click on add point features. Now we can see the cursor is turned into target symbol, which indicates we are ready to digitize. Left click on the place where we want to create point. Now we can see an attribute pop-up window. Enter the ID as 1 and enter the place name and click on OK. Now right click on the important places in layer panel and click on Open Attribute Table. Now we can see the information that we have entered on the pop-up window. Close the attribute table and create few more points on the topographical sheet. Once you have created enough points, click on toggle editing icon and click on save on pop-up window to save the digitized points. To create line feature, click on layers, then click on create layer followed by a click on new save file layer. Click on the browse button on the file name and save the file with a specific name. In my case, I am saving in the name of rail_road. In geometry type, select line. In select CRS, select our coordinate system from recently used coordinate system. Click on OK. Enter the name as root_name. Type is going to be text data and the length is 80. Then click on add to field list and followed by a click on OK. Now we can see a new layer is added in our layer panel. Click on the railroad on layer panel and click on toggle editing. Now we can see that the tool which was add point features earlier turned as add line features. Now click on the point feature in layer panel and see the button. Now it is turned into point. It is clear that the digitizing button is changing based on the layer type we select in layer panel. Now click on railroad and click on toggle editing. Click on add line features and start to digitize railway road on the topographical sheet. Every single left click on the mouse creates a vertex. Keep moving by clicking left on your mouse. To move the image on the canvas, use the arrow keys on the keyboards. If you digitize wrongly and want to go back, click on backspace on the keyboard. Use wheel on the mouse to zoom or zoom out while digitizing. To stop digitizing, right click on the mouse. Enter the ID as 1 and enter route name as Sardar Sir to Ratankar. And click on OK. Now hide the topographical sheet from canvas and see the digitized point and railroad. Click on Toggle Editing to stop digitizing. Click on Save on pop-up window to save the digitized railroad. To create polygon, click on Layer on menu bar, then click on Create Layer, then click on New Save File Layer. Click on Browser and save it in specific folder. In my case, I save it in the name of Towns. Change the geometry type into polygon and define the projected coordinate system. I assign town name as column name. Type is text and the length is 25, followed by a click on Add to Field List and click on OK. Now we see the town layer is added in our layer panel. Click on the towns in the layer panel and click on Toggle Editing on Digitize toolbar. Click on Add Polygon feature and start to digitize any area on the topographical sheet. In my case, I digitize the boundary of Sardar Sir boundary. Left click on mouse creates a vertex. Click continuously moving the mouse on the boundary for your area. Once you have reached origin point, right click on mouse to stop digitizing. On the pop-up window, enter 1 as ID and name of the area in town name, followed by a click on OK. If you want to digitize other areas, use pan and zoom or zoom out to move to other areas. Then click on Add Polygon feature and start to digitize. Click on Toggle Editing and save the digitized polygon. If you want to digitize point or line, click on the feature in Layer panel, followed by a click on Toggle Editing on Digitizer toolbar. Digitize as much as point, line and polygon on the topographical sheet and get familiar with the process of digitizing. Once you have finished the digitization, click on the project on menu bar and click on Save. In the pop-up window, select your folder and save with specific name. In my case, I save in the name of My First Project. Now, see the top left of software. We can see the name of project is changed from Untitled to our project name. Close the software and go to the specific folder where we have saved our project file. See the file myfirstproject.qgis. This is the project file what we have saved. Double click on it to open the project. Digitize few polygons on your topographical sheet. I have digitized 4 polygons and given the name of towns in the attribute table. To see that, right click on towns on layer panel and click on open attribute table. We can see the columns with the name of ID and town name. If we want to add new columns, for example population of each towns, we can add, or if we want to delete any column from table, we can delete. Now we will add a column for the population of these towns. To add a new column, we have to use New Field tool on toolbar, but it is not activated now. To activate this tool, we have to click on Toggle Editing mode, then click on New Field tool. Now we can see a pop-up window on the screen. On the name field, write the column name. In this case, it is population. If you want to write any command on the column name, we can write on the command, or else we can leave empty. Select the type as whole number, as it is going to be population numbers. Define the length of your data. In this case, I give 8, followed by a click on OK. Now we can see a new column is added in the table. To enter the information in the cells, just double click on it and enter the numbers. The cells can be editable when toggle editing mode is activated. For the training purpose, I just type few random numbers in the population column as 2550, 1578, 3247 and 1498. Now click on toggle editing tool and click on save on the pop-up window. To delete a column, we should use delete field tool. Now it is not activated. To activate, click on toggle editing tool. Now we can see delete field tool is activated. Click on it. We can see a pop-up window. Select the field that we want to delete. In this case, I select population and click on OK. Now we can see the population column is deleted from attribute table. Click on toggle editing tool and click on save on pop-up window. Add few columns and delete it for your practice. Use the available tools on the toolbar and practice. We will discuss about few more important tools in the attribute table later. Recap of today's video lecture. We have discussed about how to create new shapefile layer in QGIS, and we have created point, line and polygon vector data. We have also learned how to add or delete a column or field in attribute table. To know more about QGIS, visit www.qgis.org.